Okay, today we're going to talk about least common denominators. You know this as L.C.D. also, right? This is a very simple idea, right? What's the L.C.D. of 2/5 and 1/2? Everyone should know what 10, right? Isn't 10 the L.C.D.? So what's L.C.D.? What do we mean by least common denominator? One person knows?
I know.
Okay, how about, let's see. Let's pick somebody at random. How about Eunice? So what is this 10 telling us? What is this? What's this L.C.D.? 10. Why is it called least common denominator? This is the denominator that what? Yeah, smallest denominator. For what? What do we use this for? Eric?
When you're adding a special fraction.
Exactly. When we add or subtract fractions, don't we need least common denominator? Why do we need this? Because, Michael? Why do we need least common denominator for adding and subtracting?
You can find the best weight.
Well, you need a common denominator when you add two fractions, right? Okay, correct. So we need this. So what is LCD? So what is it, and when do we use this? When do we need it? LCD. So this is when we add and subtract fractions, right? Yeah, so I'm just kind of giving you some basic ideas to what we're doing today and giving you some, just going over these. And so what is LCD? It's the smallest what? Denominator. Okay, smallest denominator. What? That both 5 and what? 2 will go into. Is that right? Does 5 go into 10?
Yes.
How many times? What do you have to multiply top and bottom of this if you want to make this into 10?
2.
Yeah, multiply top and bottom of 2/5 by 2/2, right? And it becomes 4/10, right? So this becomes 4/10 when you multiply top and bottom by 2. Does 2 go into 10?
Yeah.
Yeah, have to. How many times?
5 times.
It has to, right? It's 5 times, so 5/5. So what do you get? 5/10. And of course, we could add and subtract them. For tonight's homework, they're not going to ask you to add and subtract. All they're going to do is rewrite them with this LCD. That's all they're going to ask you. Guess what they're going to ask you tomorrow? They're going to ask you to add and subtract them tomorrow. But just today, all they want you to do is find LCD. Okay, so first, they're going to ask you to find LCD. And secondly, they're going to ask you to rewrite with, the LCD. That's what we're going to be doing today. Is that okay? So not even this, like on some of your homework, they're just going to ask you to find the LCD. That's it. They're not even going to ask you to rewrite them with the LCD. But some of them, they will ask you to rewrite them with the LCD. Is that okay? Do you see where we're going with this? Okay. Any questions?
What does it say after that?
That both
Oh,
5 and 2 will go in, both denominators. 5 and 2 will go into, right? Isn't that what LCD is? 5 has to go into 10, 2 has to go into 10, right? But we're looking for not any kind of common denominator. We're looking for smallest. Why are we looking for the smallest? Because it's easy for us to do the math, right? You don't want to necessarily make it big. Of course, you can find a common denominator. Every time you have a fraction, there's an easy way to find common denominator. How do you do that? Tajwar?
You multiply them together.
Yeah, you multiply them together. This time it happens to be the least common denominator. But does that work every time?
No.
No. Like if you have 1/2 and 1/4, is the least common denominator 8? No. What's the least common denominator of half and 1/4? 4, right? We want to use the smallest possible, so it's easier for us to do the math, right? That's what we're working on today. Is that okay? So do you see what we're doing with this LCD today? They're going to ask you to find the LCD. Sometimes they stop there. sometimes they're going to ask you to rewrite them with the LCD. And it's easy once you know what the LCD is, right? Jason?
What about when it says complete and it has like a question mark?
Yeah, we're going to get there in a minute. So actually, that's similar to what we're going to be talking about. So very good. May I move on then to some examples? Okay, do you see what we're doing today with these?
Yeah.
Okay, good. So Jason, you're right. They're going to ask you, here's an example one. They ask you to complete this blank. 3/8 equals to something over 40. This has to do something with the LCD because they're assuming that your LCD is 40. You see what I mean? And so if the LCD was 40, do you know how to rewrite this with that LCD 40? That's easy. What can we do here? How about Jason?
Oh. You divide 40 by 8.
Okay.
Wait, no.
So how would you rewrite 3/8 with the
Yeah,
denominator?
you divide 40 by 8 and then you multiply that number times the 3.
Yeah, or another way of thinking about it is you ask yourself, well, if 8 becomes 40, they're assuming that your LCD is 40, right? If 8, your denominator is 8, if the denominator turns from 8 to 40, what can you multiply to 8 so that it becomes 40? Right? 5. Well, can I just multiply the denominator by 5? Is that okay? No, you gotta, of course, multiply the numerator. So you're basically multiplying 5 over 5, right? So it becomes 15 over 40. Easy enough? So why do they give you this? They're just kind of having you practice how to rewrite things with the LCD if the LCD was 40. You see? You get what they're trying to do? By the way, why is it okay to multiply 3/8 by 5/5? And why do we get the same value? Okay, who knows? Everyone should know. This is a review. Samuel, L, what do you think? How is it that I can multiply 3/8 with 5/5 and they are equal to each other? Why do they have the same value?
Because you gotta multiply 8 and 5 to equal 40.
Right.
Same thing on top.
Right?
And that equal, and that 5 is,
Yeah, exactly. That's what you said. What is 5/5, class? What is the value of 5/5? 1. So you're basically multiplying 3/8 with 1, right? They're gonna have the same value, but sometimes you need to rewrite these fractions with different denominators so you could add and subtract and so forth. Does that make sense? So, of course, you can't just multiply the denominator by 5. That's why you have to multiply the numerator by 5 also, right? You're basically multiplying it by 1, right? But a special kind of 1, right? 5/5, so that you get different denominator. So very simple. Let's move on. Okay. Do we always have to give you a denominator with just number, or could we give you some with variables? Yeah. So here, take a look at this one here. I got 7/4y equals to. Now, let's say the LCD was 12y cubed. Do you know how to rewrite 7/4y with this denominator 12y cubed? Right? Okay, clear? Okay, actually, let me pick somebody up. Paige, what do you think? What do you think I need to multiply 4y so that I get 12y cubed? 3y squared, right? And of course, I can't just multiply the denominator. I need to multiply also the numerator. So I'm going to multiply top and bottom by 3y squared, 3y squared. Of course, then I get 21y squared, okay, over 12y cubed. Again, they're assuming that, let's say that you have the LCD of 12y cubed, right? You're just rewriting this, right? So they're just, showing you how to change these fractions with different denominators. Yeah.
When you are doing the LCD, when you multiply the fraction, will the number always be the same as the denominator? The numerator always be the same as the denominator?
Exactly.
Like 3y squared, will it always be like the denominator is the same as the numerator?
Right, you gotta multiply. If you're gonna multiply denominator by 3y squared, you of course have to multiply the numerator by the same number. Because what's 3y squared over 3y squared? What's the same thing over same thing?
Right,
1. So we're basically multiplying 7/4y by 1. You can't change the value of this fraction, right? All we're doing is we're just changing the denominators. They both have same value, right? 7/4y is same as 12y squared over 21y squared over 12y cubed, isn't that right? That's why there's equal sign between them. You see what I mean? Yeah, so if you're going to multiply the bottom denominator by 3y, you got to multiply the numerator by 3y. So, because you're basically multiplying that fraction by 1. You're not changing its value at all. Remember, identity property of multiplication? A times 1 is equal to A. The value doesn't change. Yeah?
Can we write that as a mixed number?
No, it's fine. Improper is good. Okay, so that's great, but we have to now find the LCD, okay? So finding the LCD for small numbers like 2 and 4 is easy, right?
Yeah.
So how do you then, but of course, are they going to give you these small numbers for your homework? Of course not. They're going to give you something more interesting. Okay, so how do we then find LCD for these interesting number. So let me show you step by step how to do this. Okay, so here we go. Look, you see how I wrote 3y over 3y, 3y squared over 3y is really 1, right? That's important because you're multiplying that number by 1, right? It does not change its value. So finding LCD, I wrote out steps. There are 2 major steps. It's sort of similar to finding GCF. You guys remember finding GCF? What was the step for GCF? First step. It's same as finding LCD. Who remembers? Hold on, who remembers? For finding greatest common factor, what is the first step? Spencer? Before you look at the common factor, what do we do? If you have 2 numbers to finding GCF, this is the hardest part of the problem. Do you remember let's say I gave you 2 numbers, 125 and 75. What are you going to do before you find it? Yeah, you gotta look at its factors, right? In other words, you gotta do the factor tree. So write this down. Step 1 for LCD, same as GCF, factor each denominator completely. How do you do this, guys? How do you factor denominators completely? Factor tree. Or another name for that, fancy name for factor tree, prime factorization. Right? You factor, right? You factor each denominator completely. Just like GCF, isn't that what we did with 2 numbers? You factor them doing factor tree. Okay, that's step 1. Okay, so step 1 is same, just like GCF, but of course step 2 is going to be different. But you will see some similarity. It's actually doing the opposite of what we normally do with GCF. Okay, so write that down. Here we go. Step 2. What do we do with GCF after we factor the numbers? Yeah, what do we do with it?
You take the smallest common numbers and you multiply them.
Right, okay, you kind of set them all together. So, yes, it actually, we had 2 steps, right? It's 2 spread, right?
Oh.
Step 2 had first, you wrote down the common factors, remember? Well, we're not going to do that for LCD. What we're going to do is we're going to write this down. Write the product of all the factors. Instead of writing only the common ones, we need to write down all factors that were used in the factors of the denominators without any duplicates. So basically what we're doing is we're going to write the product of all factors without any duplicates from both of the denominators. Okay? Yeah, that were used in the factors of the denominators without any duplicates. And of course, you know how, okay, people still writing, I'll wait. Okay, then for greatest common factor, we chose the lowest exponent. You guys remember? That's what we're going to do for the LCD. We're going to have to choose the highest. So write this down. Second part of step 2, choose the highest exponent from each factors. And this makes sense because what are we looking for? Both of the denominator must go into what? LCD, isn't that right? Don't they have to go into the LCD? So we have to choose the highest exponent because we got to make sure it goes in. If you're not so sure what it means by step 2A, like without any duplication and so forth, don't worry about it. We'll do an example, it'll be clear. So turns out, finding the LCD, once you've done the factoring part, it's really easy. You could do this in seconds. Okay? So anybody need more time? Okay, again, think about what we're doing. We're looking for LCD, which means we're looking for a number that both of the denominator we're going to. Right? The smallest number that both of the denominator we're going to. Okay. Question?
Yeah, like what do we do when the denominator is like in parentheses, like x minus 4?
Good question. Hold on to that thought. We'll get there. Very good, very good. Okay, hold on. All right, so anybody need more time? May I move on to an example now? Because if I do an example, these steps will be really clear. Okay, let's do an example. So take a look at example 3. It says, find the LCD of these 2 fractions. And look, I'm so nice. I did step 1 for you. Right? Because step 1 is the hardest part. Doing the factor tree. Right? For this number. So I did step 1 for you. All we have to do is do step 2. Is that okay? Because step 2 is the one that people are sort of not clear as to what they're saying. So write this down. It says 1 over 2 cubed times 1 over 2 to the third times 3 to the 5th times 7 to the 5th times 11 to the 3rd. And then the other fraction is 3 over 3 to the 5th, 7 to the 2nd, and 17. Are we adding these together or anything or subtracting? No, that's tomorrow. Okay, we're just gonna come up with the LCD first. Of course, once you have the LCD, you could rewrite these with the LCD. We're not even gonna do that. We're just gonna come up with the LCD first. Is that okay? So look at step. So we did step 1. Look at step 2. It says write the product of all the factors that were used in the factors of the denominators without any duplicates. So what I mean by that is basically write all the factors that were used in both of these fractions, okay, without writing a duplicate. Okay, what I just said. Okay, look, what are the factors that were used? Don't worry about the exponents right now. What are the factors that were used? Yes, sir. 2. 2, what else? 3 was used, what else? 7. Are there any other factors that were used? 11. And then what else? Yes. 17 times 17. Right? So how many factors? Now look, but don't we have another 3 here? Should I write 3 again? No, that's what I mean by don't write any duplicates. Does that make sense? Just look, both of these denominators, write down all the factors that were used without any duplicates. Do you see how does that make sense? So I don't need to write 3 again. I don't need to write 7 again, even because I have 3 here and 7 here. Does that make sense? Okay. So then I'm going to choose the highest exponents, right? So look, 2 to the third. Well, I don't have any 2, right? With the factor of 2. So guess what? I'm going to just write that one. You don't have to decide. 2 to the, there's only 2 to the third. Which exponent should I use? Third. What about 3? I have 3 to the 5th. This is also 3 to the 5th. Well, there's nothing to worry about. Just write 3 to the 5th. They're the same. What about 7 now? 7 is the one you have to decide. You got 7 to the 5th, 7 to the 2nd. I need to use 7 to the 5th because both of these fractions must go into this LCD. Does that make sense? Even if I chose 7 to the 2nd, well, this will go in, but would 7 to the 5th go into this number at all? No. Does that make sense? So because we need to make sure both of these denominator must go into LCD, we have to choose the highest exponent. Okay, what about 11? 11 to the third. 17 is 17 to the first. Okay, so that's 17. Oops. So there's your LCD. Easy or hard?
Easy.
Easy. All you have to do is write down all the factors that were used on both of the fractions, right? Without any duplicates, right? And then choose the highest exponent.
What about multiplying?
Of course, yeah, you need to multiply it out, but if it's like this big, you don't need to multiply it out. If it's a small number, you should multiply it out. But yeah, this, you don't need to multiply them out. Does this make sense? Okay, ask your group members if they get it. If you don't, ask your members. Go ahead, I'll wait. Does this make sense, guys? So I bet now that you got this, I bet you could do this again really easily. It takes a couple of seconds, that's it. Here, example 4. It says 7 over 2 to the third, 3 to the second, 5, x to the third, y to the fourth, z to the seventh. And then the other one is 17 over 3 to the fifth, 5 to the second, 7, x to the second, y to the fifth. Can you find the LCD for this? Now we have some variables. Does it change anything? No, it's the same exact idea, right? We want to find a number or expression that both of these both of these denominator will go into. And again, I'm so nice, I did the work for you first. Step 1, I did that. That's the hardest part, isn't it? Doing the factor tree. I did it for you. Okay, can you then come up with the LCD? Everybody go ahead and try. You should all be able to do this without much problem. You could do this in seconds. Yeah, question?
Wait, so like when you have like all the numbers, so you want to pick the highest exponent?
Exactly, because you want to make sure both of these denominators will go into this LCD. If you choose lower one, then the other one's not going to go in, right? It's kind of like opposite of GCF, right? Okay, good. Go ahead, everybody try. Help each other out. If you're done, if you're done, compare your answer with your group, okay? Go ahead, everybody try. All right, who could help me? Okay, so with this step 1 already, I did it for you. Somebody tell me how to second step A, right? Write down all the factors without any duplicates. Who could tell me? Lindsay, can you tell me what to write?
Yeah.
Let's list all. Okay, go ahead.
I did 2.
2. Oh, don't worry about the exponents right now. Just write. Give me all the factors that were used without duplicates. 2 times what? 3 times 5 times x times y and z. Okay, you sure? Are these all the factors that were used in both of the? And 7. Don't forget the 7, right? Yeah. So, guys, yeah. Okay. Oh, okay. But do you see how if I forget 7, you see how the second denominator will not, there's no way it's going to go into this fraction. Does that make sense? Because we want to make sure both of these fractions go into this LCD, we have to use all the factors that we use. Does that make sense? And we don't need any duplicates because, you know, we're going to choose the highest exponents anyway. Does that make sense? All right, then, who could tell me what to do next? Brandon, which exponents do we need to choose for 2? 2 to the what power?
2 to the third.
Right, because that one is only 2, right? What about 3?
3 to the fifth.
3 to the 5th, very good. This one you had to decide, right? Because this one had 3 to the 2nd from the first denominator. The other one had 3 to the 5th, right? You choose the highest. And then what about 5, Brandon?
5 squared.
Good. What about x?
X to the third.
Third, good. Y to the?
Fifth.
Y to the 5th is right, because this one had 5th, this has 4, okay? And z to the
7.
7. Oh, what about 7?
7 is like to the first.
Yeah, to the first. By the way, is this the best way to write this? I have all the numbers, variables, and then a number again. Can I rewrite this with what? 2 to the 3rd times 3 to the 5th, 5 to the 2nd, times 7, right? Times then all the variables in order. X to the 3rd, y to the 5th, z to the 7th. That's it. That's your LCD. This is the smallest number that both of these numbers will go into. We have found the smallest number. This, by doing it this way, this guarantees that you have found the smallest number both of these numbers will go into. I mean, you could always find a bigger number, right? Because you could multiply this by 100,000 million. It doesn't matter, right? But this will be the smallest number that both of these numbers will go into. Yes?
Can I use the big numbers?
Say what?
Smaller.
What is your question again?
Like, you know how there's put x to the 3?
Yes?
Can't you just put x to the second, x squared?
Oh, you want to use x squared instead of x to the 3rd?
I mean, could you?
Why? Why would you write that?
Because x squared is smaller.
Oh, x squared. Okay, very good question. Guys, Tajwar, pay attention, please. So the question is here, Tajwar. Somebody's saying, well, aren't we looking for the smallest number that both of these we're going to? Why not choose x to the 2nd instead of 3rd? Could we do that? Oops, I wrote 3 again. Samuel says, wait, isn't x to the 2nd smaller than x to the 3rd? Why not choose x to the 3rd? Because after all, aren't we looking for the smallest number? Samuel, if you do this, you get it wrong. Who could answer why this is wrong? How about Jenny? Why can I use x to the 2nd here? Because we got x to the 2nd, x to the 3rd. Aren't we looking for the smallest number? Why do we not choose x to the 2nd? Why do we choose x to the 3rd? Any idea? Well, I'll come back to you. Samuel, so you want me to choose y to the 4th, right? That's smaller, right? Yeah. Why not choose 2 to the, well, 2 is, okay. Why not choose 3 to the 2nd, right? Things like that. All right. I want you to talk to your group. Okay, go ahead. I'll wait. All right, so we're going back to Jenny here. Jenny, why is it that, so first of all, can I do this? This is, I just told you, this is wrong. If you did that, this is wrong, okay? So Jenny, why is it that I cannot choose x to the 2nd or like 3 to the, 3 to the 2nd? Are we looking for the smallest number? Why is it wrong to do that? Yeah, and if I chose x to the 2nd, will this x to the 3rd go into this number? Would it go in? No, right? If I chose x to the 2nd, will x to the 3rd go into x to the 2nd class? No, it's too small. It has to go into this number. Yeah, if right? With that thought, then why not just write 1? 1 is the smallest number then, right? Does that make sense? We want to make sure both of these fractions, the denominator of the fraction, go into this LCD. So we have to choose all the factors that were used to make sure everything goes in, and we have to choose the highest exponent to make sure it's not too small. Right, Samuel? Do you understand? If I wrote 3 to the 2nd, is 3 to the 5th going to go into 3 to the 2nd? No, it's too small. Does that make sense? Do you see why it's sort of opposite of GCF? Does that make sense, guys? Okay, so this ensures that you have a big enough number, but it's the smallest number that both of them are going to. You understand? All right. Let's find an LCD for simple fractions like this. 3 over 5th, 5 over 8, 5 over 12. This time, guess what? Have I done the step 1 for you? Not really. You got. Guess what you have to do then? You have to factor the denominators, right? Okay. Do you know how to factor these denominators? You do a factor tree. Okay. Go ahead. Everybody try. I'll wait. And find the LCD afterwards. Okay. How many of you? All right. How many of you? At least for the factor tree part. 5 is just 5. That's easy. 8 is you get 2 times 2 times 2. You get 2 to the third power. You want to write these in exponential form, right? And 12 is 2 times 6. 6 is 2 times 3. So you get 2 to the second 3, right? So now instead of 2 numbers dealing with 2 numbers, you're dealing with 3 numbers. That's okay, right? You could have 3 denominators, can't you? So let's do the step 2 now. Who could tell me step 2, the first part of step 2? You have to list all the factors without any duplicates. Who could have? How about Samira? Can you tell me what to write? Let's do step 2, where we write out all the factors that we'll use without any duplicates. So 2, don't worry about the exponents right now. 2 and what? Times 3 times 5. Are there any other ones that we'll use? No, that's it, right? Now we need to choose which exponent, highest or the lowest? Highest, because it has to be big enough, right, Samuel? It has to be big enough for both of them to go in. Kevin, which one do I choose? 2 to the what power?
2 to the third.
Third, very good. Because this one has 2 to the third, this has 2 to the second. What about 3? 3 to the, just 3 to the first, 5 is 5 to the, because there's no other ones, right? That's it. Okay, so there you go. Should I leave it like this, or since the number is small enough, we can multiply it out, right? If it's really big, you don't need to multiply it out. So 2 to the third, isn't that 8? Times 3 times 5, it turns out to be 120. How many people got this? Raise your hand. Okay, so if you were to, so if you had to add these fractions, what number do you need to use for your denominator? 120 as your denominator.
So on the test, if it's easy to multiply out, do we have to?
Yes. Yeah. So, question. Aaron? Simple. So, Aaron, what do you mean? Simplify what?
I crossed out, from the beginning, I crossed out 5 to make that 1/8.
No, we're not doing it. These are separate. These are just fractions. We're not adding them or multiplying them. Sorry, okay. So we're not multiplying these. You're right. If we're multiplying these, you would cancel things out and do that. But we're trying to get you ready for adding and subtracting fractions. So before we do that, we're just going to give you these 3 fractions and come up with the LCD. Yeah, sorry. It doesn't mean multiplication. Any question? Are we good? All right, let's move on. Here we go. So look at example 6a. It says find the LCD of look, now the fractions, instead of having some numbers, we're going to have some polynomials. We get 15 over 4k minus 6. The other fraction is 12 over 6k minus 9. And Aaron, we're not multiplying them at all right now. Okay, these are just separate. Maybe I should put a comma here or something. Here, okay. So, whoops. Okay, so let's look at these denominators. Step 1, we need to factor these denominators, right? Do you know how to factor these polynomials? Yeah, you better all know how to factor these polynomials. How do you factor 4k minus 6? Oh, no, don't worry. Let me pick up somebody random. How about Carly? Is there a way to factor that binomial, 4k minus 6? You're right. You have to factor out the GCF. That's the only way to do this. Is this a difference of 2 squares? No. Only way to factor this is, even though there's only 2 terms, it has GCF. That's factoring, right? When you factor out a GCF, aren't you writing things as a multiplication? Okay, what about 6k minus 9? Who could tell me what to write for that one? Dana? Exactly. Do you see how we could factor? See, I'm kind of doing a factor tree for these denominators, but I'm just basically factoring them out, right? Do you see that? So that's our step 1. You factor the denominators, right? What's our step 2 then? You write out all the common factor. No. That's for GCF. You write out all the factors that was used without any duplicates. So it's the same exact step, right? So who could tell me what to write for the LCD then? How about Camilla? Can you tell me all the factors that were used? 2, 2k minus 3, and 3. That's it, right? So there you go. Aren't these the factors that were used in both of the fractions? So instead of just with numbers, we now have some polynomials as a factor. Is that okay? That's fine, right? And what about, which exponent do we choose? 2 to the? To the? First. There's no other 2. 3 to the? First. And then 2k minus 3 to the? First. There were no exponents at all. So that's easy. Yeah, Dana?
So like for the second fraction, this is like
Yeah, you factor out of 3. You should, yeah. What do you want to do?
instead of
No, we're not rewriting these fractions with this LCD yet. We're going to get there in a minute. All we're looking at is just the denominator. Is that okay? Don't worry about the numerators right now. All I'm looking for is the LCD. Is that okay? So what is the LCD? Do you want to leave it like this? What is 2 times 3, guys?
6.
Okay, so you should write it as 6 times 2k minus 3. There's your LCD. Yeah, question?
Distributing.
Oh, yeah, you could distribute it out. But for these fractions, once you find the LCD, leave it factor. Okay, believe me. Just leave it factor. It's going to be helpful for you. Just leave it factor. But something like 2 times, 2 and 3, you should multiply it out. Are we okay with this? Now, Dana, guess what I'm going to ask you now? Rewrite these fractions with the LCD. Okay, do you see what we're doing with this? Now, here's second step. Here's the second part. It says 6b. Rewrite each fractions with LCD. So, I want you to rewrite 15 over 4k minus 6 with this LCD. By the way, do you think it's better to write 15 over 4k minus 6 with this factored LCD denominator? Do you think it's better? Yes, it is. Because isn't it easier to see what you need to multiply? How can I rewrite this with this LCD? 6 times 2k minus 3. It's better if you leave it factored. What do I need to multiply? 2 times 2k minus 3 so that it becomes 6 times 2k minus 3?
3.
Yes, I need to multiply top and bottom by 3. Right? Isn't that how you get this? 2 times 3, you get 6. What's 15 times 3, guys? 45. Easy enough? So we have rewritten the first fraction with the LCD width of 6 times 2k minus 3. Okay, hold on. And then what about the other one? What do you need to multiply? Wasn't this 12 over 3 times after, isn't it better to write this with the factor denominator? How do I rewrite this? 3 times 2k minus 3 with 6 times 2k minus 3. What do I need to multiply top and bottom of this by? How about Carolyn? So you see how I rewrote this? We had 12 over 6k minus 9, right? So instead of 6k minus 9, I rewrote the denominator factor form. It's easier when it's factored, right? So what do I need to multiply top and bottom of this by? So that you get 6, 2k minus 3. Yeah, multiply top and bottom by 2 over 2, which is 1, right? So what's 12 times 2, guys?
24.
24. There you go. Now we have rewritten the 2 fractions with the LCD. Okay. Any question? Do you see what we do to find the LCD and rewrite them with the LCD now? Okay. Guess what? Tomorrow, what are we going to do with these 2 fractions written with the LCD? We're going to be either adding or subtracting them. Are we going to do that today? No. They're going to just go as far as rewriting them with the LCD. Does that make sense?
Yep.
Any questions? Can you do something like this for your homework tonight? All right, good. Here, they will give you something like this. 5 over x plus 2 times x plus 3. And this time the instruction is a little bit different. It says rewrite each fraction with their LCD. The other fraction is negative 3 over x squared plus 4x plus 4. Right now, do we have these 2 fractions with their LCD? No. By the way, what do you think we have? So first fraction is nice. Why? Because the denominator is already... Yeah, it's already been factored. What about x? What about the other one? Is the denominator factored? No. Can you factor the denominator? Go ahead, everybody, try. And now, not only that, they're not just looking for the LCD, are they? What do they want you to do after you find the LCD? They want you to rewrite them with that LCD. Okay, let's see whether we could do this. Go ahead, everybody, try. All right, who can help me how to factor the denominator? Everyone should have done this already. Daniel? Were you able to factor x squared plus 4x plus 4? What's the factor to? You got it. X plus 2 times x plus 2. Right? So in order to write these with LCD, do you think we need to find what the LCD for these fractions are? Yeah, so who can help me how to do this? How about Max? What's going to be the LCD? So we write down all the factors, right? And choose the highest exponent. What's the LCD for these two fractions?
X plus 2 cubed times x plus 3.
Almost. Why did you say x plus 2 cubed?
Because there's
What is the highest exponent? Yeah, you're not multiplying these out, are you? You just choose the highest exponent. This is x plus 2 to the first power. This is x plus 2 to the second. So guess what we should choose?
x plus 2 to the second.
Yeah, times
X plus 3.
x plus 2. You list all the factors that were used and choose the highest exponent. There's my LCD. Right, guys? So, is there a way to write 5 over x plus 2 times x plus 3 with this LCD? How do you do that? Multiply top and bottom of this by? Hold on, how about Audrey? What do you think I have to do if I want to rewrite this fraction? 5 over x plus 2 times x plus 3 with this new LCD. X squared plus 2 squared times x plus 3. We need to multiply top and bottom by? Exactly. Wouldn't it need x plus 2? Okay, move it up a little bit. Don't you need to multiply top and bottom of this by x plus 2? Then it will get x plus 2 squared, right? So, and do you have to multiply 5 times x plus 2? Yes. It's okay. Just leave a factor for now. Is that okay? Now, what about the other one? Do you think it's better to look at negative 3 over unfactored denominator or the factor denominator? Factor, right? Which one? What do we need for this one? Multiply top and bottom of this by? How about Serena? So for the second fraction, we need to use the LCD now. This is really negative 3 over x plus 2 squared, right? What does it need? Exactly. So we need to multiply top and bottom by x plus 3. And there you go. We have written, right, these two fractions with the LCD. X plus 2 squared times x plus 3. Is this easy? Do you get the idea? Can you do something like this for your homework tonight? So are they going to ask you to add and subtract them yet? No. All they're going to do is, at the end, write them with their LCD. Okay? That's why we did all this LCD today. Any questions? Okay.